Welcome to mobile computing tutorial. In this video, we will study the short message service or SMS. SMS enables sending and receiving text messages to and from GSM mobile phones. SMS uses the free capacity of the SS7 signaling channel. Each SMS is up to 160 characters in length. Strengths of SMS. The first feature of SMS is omnibus nature of SMS. SMS uses SS7 signaling channel which is available throughout the world. SMS is the only bearer that allows a subscriber to send a long distance SMS without having long distance subscription. The next point is stateless. SMS is sessionless and stateless. Every SMS message is unidirectional and independent of any context. This makes SMS the best bearer for notifications, alert and paging. Then asynchronous. SMS is completely asynchronous. In case of SMS, even if the recipient is out of service, the transmission will not be abandoned. Therefore, SMS can be used as message queues. The next point is self-configurable and last mile problem resistant. SMS is self-configurable. In case of web or WAP, WAP means wireless application protocol. In case of web or WAP, to connect to a service from a foreign network, the device needs to be configured by the user. But in the case of SMS, SMS has no such constraints. While in a foreign network, one can access the SMS bearer without any change in the phone settings. The subscriber is always connected to the SMS bearer irrespective of the home and visiting network configurations. While roaming in a foreign network, even if the serving network does not have an SMS sender or SMS message sender, SMS can be sent and received. The next point is non-repudiable. SMS message carries the SE. SE stands for service sender or message sender, and the source MSISDN as a part of the message header. So the message header contains the SE address and the MSISDN number. It is not possible for any application to handcraft the SE address. So we can find the origin of the SMS. The next main feature is the SMS is always connected. SMS uses the SS7 signaling channel for its data traffic. The bearer media is always on. That means the SS7 channel is always on. When a phone is busy and a voice, data or fax call is in progress, SMS message is delivered to the mobile station without any interruption to the call. Then SMS architecture. SMS are basically of two types, SMMT message and SMMO message. SMMT stands for short message mobile terminated point to point, and SMMO stands for short message mobile originated point to point. SMMT is an incoming short message from the network side and is terminated in the MS. So SMMT message is an incoming message to a subscriber. Then SMMO is an outgoing message originated in the user device or mobile station or mobile phone and forwarded to the network for delivery. So SMMO message is simply an outgoing message from the mobile subscriber to the network side. So this is a architecture of SMS, here we can see two PLMN networks, PLMN1 and PLMN2. The message will send from PLMN1 to SC. SC is the message sender. Then the message will deliver from SC to the PLMN2. That means PLMN2 is the serving network and PLMN1 is the sender's home network. Here we can see two messages, that means SMMO and SMMT. SMMO in the PLMN1 is the outgoing message and the message will send from the MS1 to SC, and SMMT is the incoming message. The SMMT is delivered from the SC to the MS2. For an outgoing message, the SMS is sent from the phone to the SC via the VLR and the interworking MSC. For incoming SMS message, the path is from SC to the MS via the HLR and the gateway MSC. So the SMMO message will go from the MS1 to the SC via the VLR and the IWMSC. Then the SMMT message is delivered from the SC to the MS2 through HLR and GMSC. Then short message mobile terminated, SMMT messages. For SMMT message, the message is sent from SC to the MS. This whole process is done in one transaction. For the delivery of MT or incoming SMS messages, the SC of the serving network is never used. This implies that an SMS message can be sent from any SC in any network to a GSM phone anywhere in the world. This makes any SMMT message mobile operator independent. Then next point is short message mobile originated or SMMO. SMMO is an outgoing message originated in the MS, where generally the user types in a message and sends it to another MS ISDN number or an application. For an MO message, the MSC forwards the message to the home SC of the sender. The SC is an independent computer in the network and works as a store and forward node with a large database. So the SC will act as a store and forward node in SMS flow. The database is used to store SMS. In SS7 terminology, SC is an SCP, service control point, within the SS7 cloud. MO message works in two asynchronous phases. In the first phase, the message is sent from the MS to the home SC as an MO message. That means mobile originated message. In the second phase, the message is sent from home SC to the receiving MS as an MT message. MT means mobile terminated message. It is possible to attempt to send an SMS message to an invalid MS ISDN number. In such a case, the message will be sent successfully from the MS to the SC. However, it will fail during the SC to the MS transfer. SMS as an information bearer. SMS can also be used in enterprise applications. Here, one endpoint is a mobile phone, but the other endpoint is a mobile application. So please consider the other endpoint is a mobile application. That mobile application will reside in a server machine. To use SMS as a bearer for any information service, we need to connect the services running on the enterprise server through an SME, short message entity, or ESME, external short message entity. SME is generally a SMS gateway. With respect to SMS, a GSM subscriber is always in control of the SC in the home network, irrespective of the serving network. Thus, if there is any SMS based data service in the home network, it will be available to the subscriber from any foreign network. In this picture, we can see the SMS as an information bearer or medium for mobile applications. We have two networks. One is the home network and the other is the serving network. In the home network, we can see the origin content or server that resides in the enterprise. The origin or content server is connected to the SC through the SME. The message from the content server to MS is a SMMT message. Here also, the message from the MS to the enterprise application is a SMMO message. The SME and the content server are outside the scope of the GSM specification, but the mobile station and the MSC are within the scope of the GSM specification. The message will send from the content server to MS, and also the MS will send messages to the content server. Then next topic is operators centric pool. As a part of SMS value added services, operators offer different information on demand and entertainment services through connecting an origin server to the SC via a SMS gateway. Such service providers are known as Mobile Virtual Network Operators or MVNO. MVNOs develop different systems, services and applications to offer data services using SMS. Many enterprises use MVNOs to make their services available to mobile phone users. Example of MVNO. Let us say few banks offer balance enquiry and other low security banking services over SMS, and customers need to register for the service. During the registration, the customer needs to mention the MS ISDN of the phone, which will be used for a banking service. Once a user is registered for the service, he enters BAL and sends the message to a service number like a 333 as a MO message, and then SC delivers this MO message to the SMS gateway. The SMS gateway is also known as the SME, connected to this service number. SMS gateway then forwards this message to the enterprise application, and response from the enterprise application is delivered to the MS as a empty message from the SME. Even if the subscriber is in some remote region of a foreign network within GSM coverage, he can send the same SMS to the same service number in his home network, and this makes the home services available in the foreign network. Hence, operator-centric SMS pull service is completely ubiquitous. Connectivity between SC to SME and SME to enterprise origin server use protocols like SMPP. Protocol between SME and origin server could be anything like SOAP. SOAP stands for Simple Object Access Protocol, or direct connection through TCP socket or through HTTP. Then next topic is operator independent push. Any push which may be an alert, notification or even response from a pull message generated by an application can be serviced by any network and delivered to any GSM phone in any network without any difficulty. If appropriate roaming tie-ups are in place, an enterprise can use SMS to send business alerts or proactive notifications to its customer anywhere, anytime on his phone. The basic network structure of the SMS push. So in this picture we can see the enterprise application. The content server is reside in the enterprise application, the SME and SC. Notification message sent as SMS MD. Here the notification messages are sent from the content server to the MS. This is the serving network. The MS resides in the serving network. Operator independent pull. Mobile originated SMS message can be routed to some enterprise SME connected to external SC. This is achieved through SAT. SAT stands for SIM Application Toolkit. SAT application running on the SIM card changes the SC number during the transmission of the SMS and forces the SMS to recognize a different SC of a different network as its home SC. Technically, the SMS is sent to the SME connected to the home SC. If a SMS service is operator dependent, the cellular operator can use this to its advantage. Enterprises need operator independent pull as enterprises have customers around the world subscribing to different GSM networks. Operator independent pull can be achieved by GSM and intelligent network technologies. Value added services through SMS. Value added services or VAS can be defined as services which share one or more of the following characteristics, like supplementary service, that means not a part of basic service but adds value to total service offering, or stimulates incremental demand for core services offering, stands alone in terms of profitability and revenue generation potential, can sometimes stand alone operationally, does not cannibalize basic service unless clearly favorable, can be an add-on to basic service and as such may be sold at a premium price, may provide operational and or administrative synergy between or among other services and not merely for diversification. We are familiar with the VAS service with the network providers like missed call alert, dialer tone, etc. are value added services. The most popular VAS over SMS are entertainment and information on demand. Information on demand has three categories. First one is static information, which does not change frequently. For example, the IFSC code of a bank is a static information. Then dynamic information, which changes in days. For example, the daily horoscope is an example of dynamic information. Then real-time information, which changes continually. Example is the live cricket score is a real-time information. Some of the common VAS examples: news or stock quotes service, session-based chat application, email through SMS, healthcare services, micro-payment services. Alert services through VAS. Proactive alert services can be of the two kinds: time-based and watermark-based. Time-based proactive alerts are sent to the mobile phone at a pre-assigned time of the day. Watermark-based proactive alerts are sent when some event occurs. Then, location-based software. In location-based services, only the information relevant to the current location of the mobile phone or the subscriber is provided. The location of a mobile phone can be determined either from the network or from the device. Device-specific location awareness requires either of the following technologies: Cell ID or CID based system and GPS based system. Cell ID based system. Cell ID of the current BTS is determined and then mapping of the cell identifier to the geographical location is performed. For CID based system, the signal strength from all the different CIDs are extracted from the device and sent to the server through a SMS. Location of the user is determined using the signal strength and triangulation algorithm. Then GPS based system. Location is determined through a GPS receiver installed within the phone. GPS provides facility to compute position, velocity and time of a GPS receiver. GPS based system is not dependent on the network operator. This is the VAS architecture. We can see the mobile station, the BSC, MSC, SMSC, SME or SMS gateway. This is the SMS gateway. The SMS gateway acts as an interface between the SMSC and the content server. Here we can see the content server. The contents in the content server is always updated. Accessing the SMS bearer. There are two ways through which SMS bearer can be accessed: using a mobile phone as a GSM modem and connecting it to the computer, or using the SMSC of an operator through SMPP or similar interface. GSM modem. Normal cell phone can be used as a data modem, which will be in a position to access the network as a normal GSM phone. Once phone and computer is connected through wired or wireless means, cell phone can be used as an external GSM modem and issue AT commands to transact data over the GSM or SMS bearer. AT stands for attention commands. AT is known as attention and are commands to the modem from the computer. AT commands can be for sending a SMS, reading a SMS, checking battery power, writing a phone book entry, etc. To read a SMS from the GSM modem, we need to ensure that the SMS is forwarded to the computer rather than the phone local store, and for this CNMI commands are used. The next one is SMPP. SMPP stands for Short Message Peer-to-Peer Protocol. It is an open industry standard protocol designed to provide a flexible data communications interface for transfer of short message data between a message sender and a VAS application such as a WAP proxy server, voicemail server, email gateway, or any other messaging gateway. SMPP client is termed a external short message entity or ESME and is connected to the SC. SMPP supports a full-featured set of two-way messaging functions such as transmit messages from an ESME to single or multiple destinations via the SMSC, An ESME may receive messages via the SMSE from other SMEs. Query the status of a short message stored on the SMSE. Cancel or replace a short message stored on the SMSE. Send a registered short message. Schedule the message delivery date and time. Select the message mode such as datagram or store and forward. Set the delivery priority of the short message. Define the data coding type of the short message. Set the short message validity period. Associate a service type with each message such as voicemail notification. SMBP protocol overview. SMBP protocol is an open message transfer protocol that enables short message entities outside the mobile network to interface with an SC. Non-mobile entities that submit messages to or receive messages from an SMSE are known as external short message entities or ESMEs. The SMPP protocol defines operations and data as set of operations for the exchange of short messages between an ESME and an SMSE. Data that an ESME application must exchange with an SMSE during SMPP operations. Subscribers to an SMS-capable cellular network may receive short messages on a mobile station from one or more ESMEs. Example of such ESME application can be voicemail alerts originating from a VMS, voice messaging system, numeric and alphanumeric paging services, informative services, calls directly dialed or diverted to a message bureau operator who forwards the message to the SMSE for onward delivery to a subscriber's handset. Fleet management applications that enable a central station to use the SMSE to determine the location of its service vehicles and notify the closest vehicle of a service request in their area. Next one is telemetry applications. Then other applications are WAP proxy server. That is the end of this topic. Thank you.